Hey everyone, welcome to Apple Pay. What happens when you tap? Pretty thrilled to talk today. My name is Stepan Hruda. If you want to track me down later, this is my GitHub, this is my Twitter. I currently work at Shopkeep. We are a point of sale, iOS-based point of sale, and a small business analytics tool for brick and mortar stores. We just raised 60 million and we are hiring in New York City, if anyone's interested. Also, if you're wondering what my strange yet oddly charming accent is, I'm from the Czech Republic. I think that's enough self-promotion. Okay, let's go to Apple Pay. First of all, who here has used Apple Pay on their iPhone? That's a lot. Who here has used Apple Pay on their Apple Watch? That's pretty great. That's some really great and very skewed data because this is a developer conference. Anyway, what I think is Apple Pay is not any kind of breakthrough revolutionary invention. What Apple did is they took some of the latest and most secure practices in the business or in the financial industry, and they combine them with very good UX and kind of consumer-facing features. So it ends up being very convenient. And arguably, this is the reason why Apple is successful in a lot of cases, because they kind of take a mildly adopted thing and figure it out in a way where it's accessible to like a wide consumer base. I want to talk about 4 things today. First of all, plastic cards, which are not really part of Apple Pay in any way, but it's pretty important to understand where, like, how payments work on the basic level. So because all of the rest, anything that like involves payments pretty much builds on top of that, especially with the payments industry having to be backwards compatible a lot of the time and so on. So cards, second of all, NFC, which is like, I guess why you guys came here. It's what happens when you take your phone and use it in a store. Third is apps, using Apple Pay inside your apps. And fourth is loyalty, which is a new feature that's coming with iOS 9. Let's start with plastic cards. As you probably know, the stripe that you have on your card is magnetic. It's a magnetic stripe. We started using it in the 1970s, so it's a pretty, what is it, 45 years now? It's pretty old technology. And it's not very different from like an audio cassette that you probably bought in the 90s. It's like one of those. I'm also told that there has to be a fire in every keynote, so I had to put that there. Yeah, so this, like the stripe on the back of your card, pretty much the exact same thing as what's inside an audio cassette. What I find interesting is, let's talk about rust for a second. So rust is basically oxidized iron, right? And iron is attracted to magnets. You might see where this is going, because if you sprinkle rust onto the back of a credit card, it effectively creates like a 2D, I think I have a second pick, 2D magnetic barcode, like zoomed in. And I'm a pretty visual person, and I find that pretty amazing that you can actually see the data stored on your card visually as a barcode. You can see 3 distinct tracks here, 1, 2, and 3. Yeah, the top one is a little harder to see, I guess, or the data is a little harder to see because it's more dense. It can fit out up to 79 7-bit encoded characters. And the track 2 is less dense. That's why you can see all those stripes so clearly. and it uses 5-bit encoding, meaning that every 5 vertical stripes are basically a single character. Track 3 is usually empty on your card. Now, what's stored on those tracks is defined by an ISO. This is the number of the ISO if you want to look it up. Here is an example of what the data actually looks like. So this is literally what is on your card. I got a handy legend here. So there are some delimiters. The important part is, as you can see, your actual card number is obviously stored on the track. Track 1 has more. It can also like have your name. The expiration date is stored in there. Important note is your security code. The like magical 3 digits you have on the back are not on the track. That's why that it's supposed to be the security code, because if someone skims your card, they still don't have what's physically printed on the card. And I think the main takeaway is there is this gray string that you can see, which is optional data. Not very important for magnetic cards. It will be pretty important for Apple Pay. So just keep in mind that like there is some optional data at the end that where you can store pretty much anything that you want, and like we are able to have that. Okay, let's talk about how credit card purchases work. Let's say you want to buy something cool, like a lobster-shaped iPhone case, I guess. You walk into the nearest lobster-shaped iPhone case store, and this is, you swipe your card, and this is the string the merchant grabs from your card. Now, you pass that string on to the merchant. The merchant is connected to a credit card processor. They pass that string to a credit card processor. The processor is connected to a payment network or to an acquirer. It's a little more complicated than this, but basically they pass your card number and all the other payment information to the network. The network kind of negotiates, makes sure that the money can be transferred from the issuer, which is your bank as the holder of the card, to the acquirer, which is the merchant's bank, and if everything goes well, the money gets transferred, and hooray, we get a lobster-shaped iPhone case. The important part here is you are pretty much at the mercy of the merchant here. If the merchant has any part of this chain insecure, like if they have a security hole, if they get attacked, you pretty much cannot do anything about this. And as a consumer, like you walk into a store and you're not gonna like check how secure they are. You just want to get your lobster-shaped iPhone case, right? So that's kind of, you literally cannot do anything about what happens with your card info once you pass it over. I think that's the key takeaway here. So that was how payment cards work, or how credit cards work, I guess. Now let's move on to NFC. So first, let's talk about what happens when you put your card information into formerly Passbook. Now it's being rebranded to Wallet. So you have your card. This is your card number. You type that into your phone. Now that gets sent to Apple, and this is the last time that your real credit card number actually gets handed over to someone, or like gets sent over the internet from you to someone. Apple figures out who actually, which brand that card is. It negotiates with one of the credit card networks, and they have to check with your bank that it's fine to use your card as Apple Pay, because they have to have, because banks are touchy about that. They have to have, all of them have to support Apple Pay. Anyway, if your bank says thumbs up, now the credit card network goes to its what's called a tokenization service, and tokenization service, simply put, is like a huge lookup table that's mapping like one 16-digit number to a different 16-digit number. So they take your credit card number, store it as like the value in that lookup table, and they assign it a different number that is also a credit card number. It's also valid. It passes all of the credit card number loan checks and everything, but it's in no way related to your actual credit card number mathematically. It's just a random valid credit card number. They generate that, they give you that, and they know how to map this token. So this is what's called a token. These are the real credit card numbers, and they assign an additional network key to it, and they pass it back to Apple, who pass it back to your phone. So now your phone has a network key and a token. This is stored inside what's called the secure element. Let's talk about the secure element for a bit. The secure element is a microchip inside your phone. Imagine it as it's a separate device. Imagine it as a chip similar to like a SIM card. Most of the time, the secure element literally doesn't do anything because it doesn't have any power. But when it's powered, it's a microchip, so it can run some computations, mainly cryptographic transactions, and it can also communicate with the NFC controller, which is another part of the phone, which enables the RFID communication and send data over it. Important fact here: the secure element is a separate hardware piece from the main CPU of the iPhone. So most of the time, your phone doesn't even have access to whatever is stored in the secure element. Now, let's say you walk into a store. You want to tap your card. You want to buy your lobster-shaped iPhone case. You put the phone close to an RFID reader or an NFC reader, I guess. That emits radio waves which power the secure element. So now the secure element is able to run transactions or run computations, I guess. And what it does is it takes your payment token, the kind of assigned credit card number that you have stored in your phone. It takes the dynamic network key that is specific to this token, and it also takes some specific information about that transaction, and it generates something like this. As you can see, this is pretty much the exact same thing as the track stored on your credit card. It generates both track 1 and 2. I just put track 2 here for it to be kind of visually easy. The important part here is, remember how I talked about these last numbers? They are used as a dynamic cryptogram. So this token or the credit card number in the track, exactly the same as your token. That never changes until you like delete your card from Apple Pay and put it inside again. The token is always going to be the same. However, this dynamic cryptogram at the end, that's going to be different for every single transaction. It's not public how it's generated. I couldn't really dig into what comes into play when it's generated. I think also your issuer kind of has a say in it, so it can be different for different banks. The main point though is it uses some kind of specific transaction information, meaning that the cryptogram is every time you put your phone close to an NFC reader, the dynamic cryptogram is going to be different. So it has transaction-specific information. I guess that's something that we are sure of.
Is that number generated just on the secure element, or does it use the CPU to do the?
All of this is generated using the secure element. The CPU doesn't come into play. So all of the computations is done by the secure element. So we generate this track 1, track 2. Also, the NFC reader has no idea that what you're tapping is your iPhone. As far as it's concerned, it can be an NFC card because those exist, which has an NFC chip inside it, and all of this could have been done by an NFC enabled card. So your merchant, the store that you walked into, pretty much doesn't have any idea what is the means of with what you're paying. So let's go through the same flow that we went through before for a credit card, but now for an Apple Pay payment. This is your phone. This is the string we just talked about how it's generated. It gets passed to the merchant, goes to the processor. Same thing. Now the processor passes it to the network. What the network does is they know that I guess it's hard to see, but your card number, this 4012 bunch of 8s, that it's a token because they have created that token. They can look it up. Now, what they can do is they need to make sure that this payment is actually valid for an Apple Pay payment because they know this is an Apple Pay token. So what they also take is the cryptogram at the end, and they make sure that they can run the exact same computation and arrive at the same dynamic cryptogram, basically. So they do like validation check, and if the validation check doesn't pass, then either because of that this token was already used, or like this transaction has already happened, or because something doesn't match, they can decline the transaction. If everything works, they switch what was generated on your phone for your actual credit card number, and now it's pretty easy to do what they were doing before, move the money from the issuer to the acquirer, and bam, lobster shade iPhone case. The important part is that generated string on your phone only good for a single transaction. And that's the gist of why Apple Pay is pretty secure to use, because even if someone violates the whole chain of trust between you and the credit card network, they only get that string, and there is not much that they can do with that string. Perhaps they can steal, I don't know, $50 from you from that one transaction, but they cannot do anything else, and you don't have to cancel your card and like go through all of the annoying things that happen when there is a credit card breach. And you are in power of what happens with your security, right? Because you chose to use Apple Pay, and what the merchant does not really affect you in any way, even if they are very insecure. I guess it affects you on a much smaller scale, which is way more acceptable.
Is the number that's generated also some way related to the amount that you're being charged, or can you?
The answer to that is I don't know. I think it is, but the exact algorithm isn't really available anywhere. So, but my bet would be I think it is. So that sums up NFC payments. Let's talk about the third case, using Apple Pay in apps. So first of all, Apple Pay in apps uses Passkit, not StoreKit. The difference between that is Passkit is basically related to passbooks/wallet. StoreKit and Apple Pay, you can only use Apple Pay in your apps for real life, like physical products or services, not digital services. If you want to sell digital services, you want to use StoreKit, which basically leads to in-app purchases, and that money is charged through your iTunes account, not through your Apple Pay card. What Passkit does is the difference between passkit and StoreKit is basically you use passkit for things like Uber or Seamless, I guess, where you get a thing delivered that's kind of outside the digital world of your phone. For StoreKit, if you want to buy diamonds for Candy Crush or whatever they sell, or if you want to pay for a digital subscription, that's what you would use StoreKit for, and your card in that case is stored in iTunes. All right, how do we use Apple Pay in apps? As an iOS developer, actually, that's from all of the things I'm talking about today. As an iOS developer, this is really the only place where you can write any code, and it's not a lot of code either. You create a PK payment request that has a bunch of configurable properties like the networks you support, shipping, billing, country, currency, all the items that are being sold. You initialize a PK payment authorization view controller with the payment request that you created. You present it as you would present any model controller. This is what it looks like. It's a standard interface, so the user kind of knows, hey, this is secure. I know this from other apps. Plus, I don't have to, like, this is not the 10th app today where I'm putting my credit card info. It's stored in my phone, so it kind of creates a strong frame of reference for the user. They can also like change some of the shipping billing information in a standard interface. Then they use Touch ID to verify the payment. You get a delegate callback, did authorize payment, and like a completion block you have to call at the end. And you get a PK payment object, which as an app developer, most of the time, what you just want to do is you want to take this PK payment object and just pass it along to one of the supported processors or one of the supported partners for Apple Pay. So if you use Stripe or something, you just give it to a Stripe SDK, and they handle all of the things for you, and then just magically your money appears in your account. I want to go one level deeper and like actually explore what this PK payment does. So if you look up the reference for that class, it has a PK payment token inside it. It also has some billing and shipping information from that authorization view controller. And if you look up what PK payment token contains, is you get basically this dictionary. So it has, and the most important part here is the data. It also has some header and signature, which kind of tells you how the data is encrypted and like makes sure that you can actually decrypt the data. There is a reference guide for this, for the payment token. But in the Apple Pay programming guide, this is what it basically says. Reading, verifying, and processing payment information requires an understanding of several areas of cryptography, such as calculating SHA-1 hash, reading and validating PKCS7 signature, performing elliptic curve Diffie-Hellman key exchange. If you don't have a background in cryptography, consider using a payment platform that performs these operations for you. So I recommend that you do that, but why not, right? So challenge accepted. However, 5 seconds later, I pretty much jump here. I'm not gonna go through how Diffie-Hellman works and like how the whole decryption works. It's a whole more complicated talk on its own. But as a shortcut, this is basically what the PK payment contains. You pretty much have all the means to decrypt everything. It's just not completely straightforward. This is also why if you have ever integrated Apple Pay inside your app, this is why you have to set up a merchant certificate and like you have to first you have to send a certificate signing request and then like use your merchant certificate. And you have to hold on to your private key. Pretty much all of this can be handled by an Apple partner if you don't want to do this, which I recommend. As you can see, this is pretty much standard payment information for an online payment. It has, again, your credit card number and some specifics for the transaction that can be handed over to the processor, and they know how to process this data and transfer the money from your account to from someone else's account to your account, and boom, you have money. So that sums up how Apple Pay in apps works. Lastly, I want to talk about loyalty. Loyalty is a new feature that's coming with iOS 9. If you haven't caught at the last dub what it does, a quick recap: you walk into a store and you want to pay with Apple Pay. On your phone, you have a credit card and you also have a loyalty card for the same store. Let's say you walk into Walgreens and you have your regular credit card from your credit card company, and you have a Walgreens loyalty card stored in your wallet. The promise of this is, in a single read, when you're paying with the credit card, your loyalty information gets transferred at the same time. So Walgreens knows who you are. They can track your purchases, do all of their analytics and all that, but you also get your discounts. So the idea is no hassle. Everything happens in a single tap. You don't have to do anything. All you have to do is to have a loyalty card inside your wallet. Now, how does this actually work? So there is a session on wallet at the WWDC 2015. It's called the wallet, the home for Apple Pay, whatever. The explanation in the session is pretty much just 10 seconds of hand waving and saying, hey, this is new, come talk to us, this works somehow, and they don't really say what it does. The gist of what is actually new in Wallet in iOS 9 is, if you use Passkit and you are creating a pass, there is this pass.json file, which you probably know about if you ever used it. There is a new field in there, or a new dictionary there called NFC. You can assign a value inside that NFC, like a message, which is the loyalty number of the customer, and also an optional key. I have no idea how this works from now on, so this is going to be just some speculation. I've tried to talk to some hardware partners. I've tried to talk to Apple, but I don't really care about it that much, so I didn't get any answers yet. But this is how I think it actually works. So just take that with a pinch of salt. You have your card stored in your phone in the secure element, and in Passbook you also have a bunch of other passes, right? And the passes have what's called a merchant identifier, I think, which is a reverse URL of every pass, which Apple guarantees to be unique because you set that up in the developer portal and there are no conflicts in there. So that's guaranteedly unique and guaranteedly yours. Now you have a bunch of different loyalty cards in there. So when you walk into a store, that store's NFC reader, that's why they're integrating with hardware partners. I think that has to have that merchant identifier and basically transmit it when it's asking for the Apple Pay card. So what the phone actually does is, if apart from the regular request from a payment card, it receives this string. It goes through all of the passes that you have in Wallet. It finds the right one that matches the merchant identifier, and with the card, it transfers also your loyalty program number. That pretty much sums up what I want to talk about today. There is a 360 iDev app out in the App Store. If you don't have it, download it. If you experienced any of these emotions, everyone will be happy if you send back feedback. These are some sources that this is based on. And questions?
How does Touch ID play into all of this? Does that have anything to do with the secure element, or is that just process?
Just for the recording, the question is, how does Touch ID play into all of this? So Touch ID is stored in a separate hardware device, which is called a secure enclave. Both of them have like SE as abbreviations. I don't know why, but it is a completely separate concept. Touch ID is mostly replaceable by passcode, right? So it is used as kind of authentication means, but it resides in its own hardware, secure hardware device. Any other questions?
Is there a way that a terminal is set up for NFC payments? Is there anything that needs to be done for them to accept Apple Pay specifically, or does it not matter?
Question is whether a terminal set up for NFC has to have anything done for Apple Pay payments. The answer is no. The terminal doesn't know anything about Apple Pay, so Apple Pay is pretty much being backwards compatible and emulating like an NFC card. Cool. Thanks for coming. We'll be happy for feedback. Hope to see you guys at the party later tonight.